Stuart Hughes, CDIO of Rolls-Royce Civil Aerospace. Yeah, so I spent 20 years of my career working in the .com industry. So the first 20 years, I worked for companies like moneysupermarket.com, laterooms.com, and I was part of the early team at the Hut Group. Before working at Rolls-Royce, I was the group CIO at JCB, the excavator company, and I joined Rolls-Royce just over 2 years ago now. So at Rolls-Royce, we split IT into three sections really. So core IT, so the service desk, the mature enterprise systems that we run. Digital, which is the digital products and services that underpin the intelligent engine, which is the product that we produce in civil aerospace. And also data, so R Squared Data Labs is the area of Rolls-Royce where we take huge data sets and make really insightful insights to make better decisions. My role as CDIO in civil aerospace means I spend a lot of time ensuring we have the right strategy for the core IT piece, but work with the central team to deliver a lot of that. I have full responsibility for the digital area, so all the way from the application right down to the cloud environments and the support that it sits upon, and exactly the same in the data area as well. So we have accountability and autonomy where it's really important for civil aerospace and where it gives us a competitive advantage. So at Rolls-Royce in civil aerospace, one of the really core concepts to our product is we offer power as a service. So we basically charge for our product per engine flying hour, and that's fixed at the start of the contract with the airline. And then for that remuneration, what we do is we use digital products and physical services to ensure that the engine is always safe, ready to fly and available to the airline when they need it. So very much like your car, where you move from paying for a service every 12,000 miles or every 12 months to variable servicing where it's only serviced now when it needs to be serviced. So a really important part of our intelligent engine architecture is our blue data thread. So the blue data thread is the connection between the engine that's in service and the cloud platform that we monitor and we process all of the data upon. And what we're doing really is taking both snapshot data, so point in time data at different parts of the flight, and also data that's continuous, so right through the flight, and analyzing that data very, very close to real time within a few minutes, making sure that we understand exactly what's going on in the engine, and that we understand that when that plane lands, that we understand if there's any maintenance needed, if there's any reviews needed, and we can make sure we have the right people there to do the job as quickly as possible and get that plane back into service. So it's just so important. If you're an airline, the worst thing that can probably happen is that one of your planes can't take off because of a mechanical reason. If that happens, it can affect up to 8,000 people. You can have 10, 15 planes in the wrong place in the world because it breaks the chain of everything that follows on from that flight. So us making sure that we avoid any unplanned maintenance events is really core to what we do. And we make sure we do that using our data and our analytics platform. So what's really important part of the digital strategy for Rolls-Royce Civil Aerospace is to make sure that we can use our digital products and services to support the expansion and the growth in the fleet. So yes, we may build 300, 400, 500 new engines each year, but actually all that's doing is increasing the number of planes out there that are Rolls-Royce powered, which are in the tens of thousands. So what we need to do is take the data that we've got from the engine monitoring and really optimize the maintenance in every way possible. So optimize for the service for the customer, optimize for the cost, optimize for sustainability, so only replacing parts when they actually need replacing. So think about your brake pads, you could replace them before they really needed changing on your car. again, it's a very similar concept where we have a life limited part and we want to replace it at the end of its life, not halfway through. So it's a really important part of that. So the best way to describe it is when an engine leaves our assembly and testing facility, we have a record in our digital twin for that engine. It contains everything that went into it, every part, where the part was manufactured, who fitted it, all of those kinds of details are stored in our digital twin. We then create a forecast for the next 30 years, which is pretty much the life of an engine. And that forecast is actually the most important thing that we've delivered recently is that forecast is now very specific to that engine. So when we build an engine, we actually know the routes or the mission that it's going to fly with the airline that we send it to. So when we're looking at the maintenance plan, we can look at what kind of air is it going to fly, what kind of land is it going to fly over, what kind of wear and what kind of maintenance regime do we know from the data that we've had in the past and our machine learning algorithms will that engine need for the next 30 years of its life? And of course, we continually to update that forecast and continue to change it as it changes what it does in its life, you know. So it's a really, really important part of that. And again, it's taking the data in really quite big batch processing, running lots of different scenarios and simulations, and then working with the airline to choose the optimum for them. You know, so it might be better for them to bring an airplane in just slightly a bit earlier, because actually it's going to be near a repair shop or it's going to be the most practical thing for them. And we just work with them to optimize the whole, because I think that's one of the things that's sometimes missed with artificial intelligence or analytics, but actually it's a great indicator to support a human, but actually it's better that the human makes the better decision, and that's kind of where we are right now. So it's been a huge part of the last couple of years that I've worked on, where we've really, really optimized the way we understand and we maintain, and thus we execute the maintenance plan in a much better way. So the latest generation of our intelligent engine platform was required because the latest generation of our engines just produce so much more data. There's hundreds of sensors recording data each second. So what we saw is we moved from, in our previous generation, the data would fit on a floppy disk, to generating about 0.5 gig of data per flight, per engine. So you can see, if you're going to analyze that in real time, you're going to have some serious horsepower. So, our previous platform was on premise, it's very good, but actually it had limitations that we could maybe run one simulation at a time, whereas now we can run 100 simulations at a time. And what's really important is we run 100 simulations and we only pay for the milliseconds that it's running the simulation, and then the cluster is turned off again and we stop paying. Whereas in the past, of course, we'd fixed our capital investment. There was no capacity to burst, there was no capacity to shrink. So it was very, very fixed. I think the other thing that the cloud has given us is just so much more flexibility. By embracing Microsoft Azure, embracing Databricks, embracing just really modern platforms, you start to see things that you can do that you wouldn't have contemplated before, because the art of the possible is so much richer. So the biggest challenge I had joining Rolls-Royce, and probably the bravest decision I had to make, was to speak to the central IT team that actually at that time owned the platform and had started to execute the program to create the new generation of technology, and influence them to move that back into civil aerospace. For me, it's really important that my team either deliver the products and services, digital products and services, that really give Rolls-Royce Civil Aerospace competitive advantage in the marketplace. And for me, you think of someone with a background in a .com, it's very much about connecting with the end user or the end customer. It's about being very, very connected to the business. Most .coms are the business. The IT platform is the business. And it felt to me, having that disconnection, having a multi, group hop to be able to implement the platform wasn't the right thing. And for me, it was a really important thing to move those people back into civil aerospace, connect them back with the business people, connect them back with the product specialists. And really it's helped us leverage even more benefit from the platform rather than have that formal handoff, that formal project. I guess the final piece is it's allowed us to move from being a project team with a project level investment to a product team that will exist forever, where all we're really doing is changing the order of the priorities in the backlog, and the team are working through that. And that's what agility brings. If you can connect the product owners or the people who know what they want with the development team, if it's very close, if it feels one even though they maybe have different line managers or are part of different departments, then that's the best conditions that you can have to create real agility in software development. So when you work in a .com, actually one of the companies we all look towards, maybe at the time, was Spotify, and the creation of product teams and the definition of autonomous teams with a clear mission, autonomous teams that made the right decisions themselves without a huge hierarchy. And I'm pretty sure in the whole of the UK, but definitely in the Northwest, ourselves, Auto Trader, all of those Money Supermarket, all of those kinds of companies adopted that mantra of it's about having teams with great authority, allowing them to do what's right and allowing them to create products. And that move away from projects that have a fixed time, have a fixed scope, and move much more towards product teams that will exist forever. And actually all we're doing is changing the priorities that come in. So when I became Group CIO at JCB, I entered a world where everything was projects, and it just kind of was really strange for me that all these people came. We seemed to waste 2 months on board and everybody and getting everybody's laptop to work and permissions. They'd do some work and then you'd spend another month closing everything down again, and then 2 months later you'd go through the cycle, and there was just a huge amount of waste. So for me, everywhere I want to work, whether I'm the group CIO or a divisional CIO, really what I'm thinking about is how can we create small permanent teams with autonomy and with everything that they need to succeed at great speed. And I think that for me, that's an absolute building block of the departments that I use. So for me, when I worked in a .com, it was called being disruptive, right? Everything we had to do was being disruptive. It didn't matter what it was being disruptive. And of course, when I went to JCB, and it's more of a mature, more of an established company, being disruptive wasn't necessarily seen as a great thing. So really there, I started to change the language to be much more around enterprise agility. And enterprise agility to me is the ability for the strategic people in the business to set the direction of where we need to get to, and then to allow the software development team and the backlog team to work together to find the best way to get there as fast as possible, and really to develop as fast a feedback loop to test, are we actually progressing, to test, will we actually get where we want to go as quickly as possible. And to do that, I see no other way other than to connect the people who make the commitment to generate revenue, save money, with the people who help them deliver that. And I couldn't think of anything more frustrating than, making a commitment where I was going to save or generate £1 million, then I pass that to someone else, who passes it to someone else. I just feel helpless. I just couldn't cope with it. So, for me, maybe growing up in that .com, we need to do it. We need to do it fast. We need to disrupt. Maybe it's a language change, but actually the behavior is the same, which is have absolute clarity on where we're going, but then use iteration and use test and learn as a method to make sure we know we're getting there, and turn things off that are not working. It's something that in a project world, people are always unwilling to turn things off because they're always about to fix it. They just need another week. But actually, if you've got that empirical data of we showed it users, or we ran the model and we know we're progressing, or actually, we know we're not going to find a way forward. So I'd like to give a really good example of that, if that's okay. And if you think about what's gone on in COVID, there's been a huge disruption to everything in the world. There's been a huge disruption in Rolls-Royce as we've seen a dramatic fall in our engine flying hours. And of course, we've seen a fall in the demand for new aeroplanes, which leads to a lower demand for new engines. We had a team of data scientists working really hard on optimizing the inventory that we have to build new engines. And, are we bringing parts in too early? Are we bringing parts in too late? And how is it affecting our assembly and test KPIs and metrics? And how could we improve them? One of the things we had spent a lot of time, and we'd create some great models, but actually one of the things that COVID did was the demand signal for new engines was just reduced so dramatically that actually the data scientists didn't need to say it, but we just didn't need to order any more parts. So for me, the key there was to acknowledge it, to put all the models and everything we'd done into a source control system so we kept those assets safe, but to let the business get on with it, because they didn't need us to tell them that they didn't need to order any parts. They already knew that. So get out the way and go and focus on something else. And actually what we were able to do was take that team of data scientists and repurpose them onto really being able to understand which planes are flying and the engine flying hours that we will be paid for, and also looking at the forward schedules from the airlines and understanding what flights the airlines were planning to fly. But then I think what was really clever is we overlaid on top of that a new data set we bought, which was internet booking traffic. So we started to see, okay, the airline says they're going to fly, but they haven't sold any tickets, so we probably think they won't fly. So it was brilliant to be able to acknowledge we weren't going to progress in one direction, pivot to something that was really, really important for the company. And actually now we just have this great new capability that allows us to understand the schedules and understand the likely engine flying hours in a way that we've never understood before. One of the real benefits of adopting a cloud platform is its scalability. And of course, everyone knows that comes from its elasticity. It also is great because you only pay when you scale, right? So you can plan for that and you can optimize your costs. But for Rolls-Royce, that's actually been a real game changer. So one of the problems in legacy legacy applications where they're on fixed infrastructure is often that the only people that can access that application are the ones that use the official interface and the official tools that come with the application. And you can't really allow employees or trained members of staff to go and run queries on that production system. And that was a limitation in the past. It was a limitation in terms of scalability and you're not wanting to affect application performance. With the cloud, what we've been able to do is open up the data set that previously was kind of locked away or siloed away into the application and make that available on a much, much wider basis. So we now store the data in a data lake, as we've talked about. Of course, the application runs and carries out its analytics, but actually what we've been able to do is open up that data set to a wider population of people within Rolls-Royce, and we know we can do that safely without affecting the performance of the core application because we have the elasticity of the cloud and we have the elasticity of its performance. So what we've overlaid on top of that data lake is Databricks, which is, in my opinion, the best data analytics platform out there. And at the same time as the application running the models and analytics that it does, we allow our data scientists to step in and run custom models or develop new models on the same data set without affecting service. The other thing that we're starting to be able to do is now open that up to a wider population. So I do like the term citizen developer. And what we've been able to do is provide a safe way for our engineers to be able to access the data on the platform without worrying about the impact that it's going to have on our live application. So I see the future of the CIO role to be a part of the leadership team of the business. So I sit as part of the civil leadership team leading the civil aerospace division, and that's a really important part of my role to me. It was one of the big reasons that I joined Rolls-Royce in this role. I often find that as the group CIO, you're neither part of the executive team leading the business, nor are you part of the division. You're kind of one of these people off to the side, and it's very difficult to know which team you're in and feel part of a team. And I think that's one of the things that most CIOs want to overcome going forward. As a group CIO, it's very, very difficult to leave the day job behind, leave the running of the enterprise systems, leave the running of email, leave the intricacies of the service desk and what one of the service desk agents may or may not have said to somebody senior that's upset them. You know, it's very difficult to leave that behind and focus on driving the business forward, you know, creating digital products and services that move the business forward, or supporting my colleagues in the division on the opportunity that digital technology provides, the opportunity that data can provide, or even how we can use more traditional enterprise systems better to feed all of those digital systems and give us an even better differentiation. So for me, I think one of the real benefits that Rolls-Royce has had over the last few years is we have a centralized IT director. That person runs the service desk, they run the on-premise infrastructure, they run the enterprise software teams, SAP or the Siemens PLM system. So they make sure that everybody's laptop works, everybody's mobile phone works, that the network's constantly upgraded. So that I have that really solid enterprise foundation already in place. And what that allows me to do is look at how the business's architecture needs to change, how we need to change some of the digital capabilities or the IT capabilities over the next 5 years, and make sure that I reflect that in the civil, digital and IT strategy. I think that's a really important change that happened at Rolls-Royce. We moved from having one group IT strategy to having divisional digital and IT strategies, but of course they were all coherent around the shared services, the enterprise systems as best we could, because for me that's the best. How can it not be the optimum that there's a person in the center that really cares about enterprise systems, really cares about the user experience, really cares about laptops and making sure we get the best deal of that, and gives us that best shared services wrapper, but also having divisional CIOs and CDIOs who really understand the strategy of the business, understand some of the challenges that the business has, and understand some of the capabilities that will need to be developed over the next 5 years, and can cross that barrier and can communicate with the business leaders on what it will take, but can also communicate with the central IT teams on some of the core enterprise tools that we may need to change or we may need to add. I also think that the future of a CDIO is that you will have to understand how to create, manage and support digital products and services that are very specific to your product and absolutely underpin your product. If you think about the intelligent engine platform, the engine could not fly without the intelligent engine platform giving permission for the pilot to take off. In the same way as obviously having the intelligent engine platform without an engine would be completely useless. So it's completely harmonious, digital tools, the products and the physical services all working together to provide a better customer experience for our customers.